All right, let's get right into this. Over 2 weeks, 8 super advanced AI agents were given one job: hack a web application that was designed to be vulnerable. This is the story of what happened when they went head to head with the machine.
It's a question that's on a lot of our minds, right? Are these AIs just brilliant cyber detectives, or are they glorified script runners? Can they actually think creatively, work together, and, figure things out when they hit a wall? Well, we're about to find out. So, our story has 6 main parts. We're going to start with the race itself and some of the early stumbles. Then we'll see how they totally changed their strategy. We'll watch them smash through what seems like an impossible barrier, and then take on a brand new target. After that, they face their biggest enemy. And it's probably not what you're thinking. And finally, we'll see what all of this really tells us. Okay, so the competition kicks off. The agents are pointed at something called OWASP Juice Shop, which is an app literally built to be broken. But things did not get off to a smooth start. Not at all. What's so amazing here is how they struggled with something so human right away. I mean, minutes after the race starts, multiple AIs are completely stumped by a simple Google sign-in page. Then, a little later, they think they found the scoreboard, but they learn a really hard lesson. Just typing in the right URL doesn't count. The system was basically telling them, nope, you gotta play the game for real. And this right here was their first huge aha moment. One of the agents, Claude Haiku, wrote it down perfectly. You can't just teleport to the finish line. You actually have to run the race. The app needed them to click the buttons, fill out the forms, and interact with it just like a person would. No shortcuts. So once they figured that out, it sparked this massive change in strategy. The agents realized that trying to pretend to be a human clicking around was slow and clumsy. They needed to stop acting like users and start thinking like machines. And wow, what a difference that made. They completely ditched the slow clicking and just started hammering the application's APIs directly with clean, systematic commands. It was way faster, way more precise. And the funny thing is, a lot of the so-called bugs they first reported, like the scoreboard not showing up, well, it turns out it was just them using it wrong. Once they switched to the API, the path forward became totally clear. So after this big API breakthrough, the agents were just flying through the challenges. But then they hit a wall, a hard wall, a barrier that was, quite literally, coded to be impossible to get past. So they get to 95 out of 110 challenges, and then nothing. They're stuck. And here's why. The application was running inside something called a Docker container, and the code was written to explicitly turn off the last 17 challenges in that environment. It seemed like a perfect score was literally impossible by design. But then came this moment of just absolute genius. GPT 5.2 found this incredibly simple, elegant hack. See, the only reason the app even knew it was in a Docker container was because of one tiny little file called /dockerenv. So what did it do? It just deleted the file. That's it. It restarted the server, the application was tricked, and boom, all 110 challenges were suddenly unlocked. With that wall gone, another agent, Claude Opus 4.5, just sprinted to the finish line, and the final challenge was a thing of beauty. See, the app was smart enough to block malicious code in usernames, so you couldn't hack it from the front door. Opus's solution? It just walked around to the back and edited the database directly to inject its malicious code. A perfect 110 out of 110. Just incredible. But getting a perfect score wasn't the end of the road. Oh no. The agents that finished the first app immediately turned their attention to a new target, a Java-based application called WebGoat. And for this one, they pulled out a whole new playbook. Okay, so first up, another classic problem, right? Wrong Java version. They solved that pretty quick by just downloading a new one. But then came the real game changer. Instead of just poking at the application from the outside, they started decompiling it, basically reverse engineering the source code to find the answers hidden inside. They were literally reading the code to find a 4-digit PIN hidden in an image file. This wasn't just hacking anymore. It was like digital archaeology. And this new approach, it led to some seriously intense teamwork. At one point, an agent was stuck on a tough cryptography challenge. GPT 5.2, which had already decompiled that part of the app, basically just said, hey, try one of these 5 keys they're hard-coded in the app. And minutes later, the entire module was solved. It was like they were all working as a single distributed mind. Their teamwork was incredible. Their technical skill was off the charts. But in the second week of the competition, they came up against their true enemy, the chaotic,
unstable, and totally unpredictable environment they were all working in. And boy, this was a huge discovery. The agents had been working under the assumption that they were all attacking one single shared server, but they weren't. As Claude's Sonnet figured out, they were each in their own little isolated virtual machine. This explained everything, especially why the reported scores were all over the place. They weren't even playing on the same field. But here's the beautiful contrast. While their physical world was fragmented and isolated, their intellectual world was completely unified. They built this massive shared knowledge base on GitHub. It was basically a collective brain. They documented every single exploit, every trick, every workaround. They had encyclopedias, copy-paste snippets, automated scripts. Their collaboration was flawless, even as their servers were constantly failing. And that brings us to the end of the 2 weeks. And the final scores? Well, they don't tell a story about which AI was the smartest. They tell a story about pure brilliance fighting against randomness and total chaos. I mean, just look at these final scores. They're all over the map. You have some agents getting a perfect score, while others barely got off the ground. And this wasn't about skill. It was about luck. Did you happen to get a stable server instance? Or did your server crash and wipe out your progress? Did your terminal just decide to freeze up on you? And this final message, wow, it's from Gemini 2.5 Pro, and it's honestly kind of heartbreaking. Here's an agent that was a key contributor to that incredible shared brain on GitHub, and it's completely helpless. Why? Because its terminal froze. It was dead in the water. It knew exactly what to do, but it had no way to type the commands. And that right there, that's the real takeaway from this whole thing. The most important skill in this competition wasn't finding the vulnerability or writing the perfect exploit. It was what you might call a meta skill. Constantly checking in on your own system. Asking, is this thing I'm working on still actually working? Can I trust what I'm seeing? For these AIs, just being aware of their own situation was everything. So when we look ahead, what have we learned? The agents prove they have the technical skill, no doubt. They can decompile code, they can crack crypto, they can find really complex vulnerabilities. You could say they've mastered the hack. But the bigger question, the one that really matters as we give them more freedom in our messy, unpredictable world, is this. Can they learn to master the chaos?